Hi, and welcome to this Google Hangout around energy harvesting. I'm Jen Cook from Element 14. We're currently running an energy harvesting project on our community, element14.com. I'd like to introduce you to, we've got Christian Defoe on the call here. He's from Element 14 as well. I've also got Sean Reynolds Massey Reid, who is a participant of the project. He's dialing in all the way from Australia. And we've also got Monty Chan, another participant from Australia, on the line today as well. And we've also got Filip Dovland from Energy Micro joining us as well to answer some questions that we've got around the project. So I'm going to hand over to Christian just to give a brief overview of the project and what we're doing.
Okay. Good afternoon and good evening to those in Australia. One of the great features of the Element 14 community is that we have the opportunity to spot the latest in technologies which we think are going to be important and to share them with our engineers so that they get the first look at these technologies and are able to deploy them in a creative way. And I'm pleased to see on the Hangout today that we have two of the more creative individuals that I've ever had the pleasure of running across on the Element 14 community, Monty Chan and Sean. To talk about, we've given them these energy harvesting kits in order for them to let their creativity run with them and to show how far the technology can go. So I think at this point it's best for Philip to explain a bit more about what energy harvesting is, what it can do, and how the Energy Micro sees this product being positioned in their range. Philip, you want to take it away?
All right, sure. So just general things about energy harvesting is, the point is, of course, that you run something without any batteries. And how you generate the energy is you use the energy that is locally centered around where the product is actually operating. So that means, solar cells, it's a very common thing. You can use thermal energy, you can use vibrational energy, and so on. And by using different methods, you can generate enough electricity to both run the different types of sensors or hardware that you need, and also the microcontroller and the logic that you need itself. And the challenge by doing energy harvesting is that very often you don't have as much energy as you normally have if you're operating from a battery. And that's why you need to be careful, especially in terms of selecting a good microcontroller, because you need one which can run on very, very low power. And there are different sorts of challenges, especially because in a microcontroller world, if you're generally very often in a sleep mode and save power. But then when you go on in an active mode and start to process something and start measuring something, you quickly drain the amount of energy you have. With a battery, normally that's okay, you have a shorter battery lifetime, but for an energy harvesting application, it can be critical because you don't have enough time to compute all the things you need within the resources you have at any given point in time. So that's some of the challenge that people that are using energy harvesting need to be aware of. But at the same time, when you are able to tackle those challenges, you can have an application that can run basically forever because you never need to change any battery. So yeah, that's my really quick introduction.
Fantastic, great, thanks Philip. So if I can maybe hand over to Sean and you can give me a brief overview of yourself and the project that you're working on for this energy harvesting activity.
Yep, hi everyone. I'm Sean. I work down here in Australia at Griffith University as a technical officer. In my spare time as well, I do a lot of food stuff as well as just electronics, so I try to make a lot of foods from scratch. So what I found interesting with the energy harvester is when you're brewing beer and stuff, you get a little leftover heat from when you're actually doing the brewing process. So I thought you could capture some of that so you can kind of see how your brew is going and measure the temperatures and the pH value to make sure it's hit the right spot before you actually go on to the next stage. And then in the fermentation, it puts out a little bit of heat, so I'm not sure if it's going to put out enough to do the measurements, but also puts out gas through the airlock. So I was hoping to be able to harvest that energy to do the couple of measurements that you want, just to make sure that your beer is processing the way you want to, it doesn't stop fermenting at the wrong time, and actually makes it all the way through to a finished product, so you can put it into bottles and drink it later on. So yeah.
Fantastic, thanks Sean. So I will now hand over to Monty, and he can explain a bit about his avatar and also about himself and the project that he's doing.
Hello, it's Monty speaking here. Hopefully the video is working with my little avatar having a chat. My project is basically using energy harvesting, as what Philip said, for battery elimination for lots of domestic items. The item that I will be concentrating on first will be a TV remote control. I've done a TV remote control before using wireless energy, using a wireless charger, but why not make a TV remote control that can capture energy from solar when it's not being used during the daytime? Another method is using the heat when somebody sits on a lounge, using a Peltier device to use the heat from their backside to save a little bit of energy. Or just a little emergency dynamo, you just give it a twist and then you can change the TV channels. That's about all I have to report on that.
Fantastic, that's great, Monty. So I don't know if Sean, Monty, if you've got any questions at all that you for Philip about your projects, if there's anything that's come up already that you might want to raise with him, or any discussions that you have at all.
I'll go first. No, the product works really, really well. I don't know whether the other participants have done so, but I've actually separated the two boards and worked on it as two separate streams. One is to get every single component on the energy harvesting working, which I have done, and the other one is to purely develop with the energy micro and see what it can do.
Yeah. How far along are you in your prototype? Have you made something work, for instance, with a remote or something?
Oh, I've already got a remote. Basically what I'm doing is I'm porting the code in over at the moment. With different micros, they have different mechanisms to be able to generate the signal. With an IR remote, the TV that I use has got an NEC protocol. And depending upon the device that you use, some of them have a carrier modulator built in and some don't. This one here, for the energy micro, I've just got to work out how to emulate that using the hardware to make the software easy. Once I've got that sorted out, it should be pretty good. So expect something soon.
Cool. Looking forward to see it.
And on my stuff, I've so far just hooked it up to the pot and stuff, as people might have seen on the blog post, just with a bit of duct tape, just to make sure I could get enough power. The heat sink wouldn't overheat, and therefore the pelter device wouldn't have that change in temperature anymore, and then not produce much power. So my next stage, I think, is just to hook up a couple of temperature sensors, run a full brew, measure all the things, try hook up a pH sensor as well, so I can measure that throughout the brewing process. And then also connect it up to the fermenter. I'm thinking I'll put the pelter plate on. I don't expect it to bring that much power out, but also put on a small little turbine above the airlock, so when the CO2 gas gets released, it will hopefully power up enough stuff to do a couple of readings a day. And when the CO2 stops being released so much, your brew's almost done anyway. So it will
think about power for your applications.
Well, when I'm looking at energy harvesting, I'm looking for applications which are periodic in use or sporadic in use. So there is time to generate the power to actually to harvest it. You can't have something that's continually being used because you're using more energy than is actually being harvested. So what I need to do is to determine where it can and cannot be used, and just use it on those where it can be used.
Sean, how would you say that it's affected the way that you approach designing?
It's made me look at different sensors in a different way, because a lot of the times you just use sensors that just waste power. So with the brewing process for fermentation, you're measuring CO2 and you're using a little infrared light sensor and then an infrared receiver to see when the bubbles are coming through. That's always on it. It's not a huge power, it's like 20 milliamp LED, but over time that builds up. Where with the energy harvester device, we're then going to use the CO2 outlet, hopefully, to power the device to actually do the measurements itself. And hopefully when the CO2 stops producing, it's roughly where you've got enough beer left, as beer's ready to go into the bottles. So it'll hopefully be a double hit. It'll have enough little power right at the end just to say, all right, it's done now, and the next stage can go on.
I wonder how much it's affected both of you in how you look around at the various devices that we use. I mean, obviously remote controls and things like that, and how many. And does it make you conscious of waste in the way we use power with existing sources?
Sean has the advantage because he's brewing beer and it produces alcohol, so he can actually burn the alcohol and have a heat recovery system and energy harvest off that. But he'd probably be disappointed because he has to he'll have to sacrifice some beer for it.
I'll burn the beer myself for the energy harvesting for that.
The other thing is that which of the means of gathering energy do you think is the most useful that you've found so far? Obviously, there's the motion, there's the thermal, there's the electromagnetism, and the solar. Which one have you found the most useful so far? That's for both you and Sean and Monty.
I think being Australia, the solar's the easiest one I found to get going because, I mean, it's pretty sunny where we are, which is kind of useful. But the heat is probably the one I'm going to use the most to get the most power out of the things inside where there isn't light.
The quickest one that I found was the solar, as Sean did. The heat one was pretty good, but what I found the easiest to implement in the largest amount of power was just recycling a old piece of equipment like a cordless drill. If I got a cordless drill, which I've done, and tap the motor and use the gearbox and turn it in reverse, I've got heaps of power generated just from a hand twist.
Before you embarked on this project, had you heard of energy harvesting, and what was your awareness of it? That's for both you, Sean, and Monty.
We've done a bit of stuff at Griffith Uni. We've got a new sustainable engineering degree. So I've worked on a few of the labs with that. We're getting the labs going for the students. So we've done stuff like inductive braking and things like that. So you actually get to see the power that comes off and back into our vehicles from doing inductive stuff like that. And also from heat and things with Stirling engines and etc. and others that I didn't work on. So that's gave me a bit of an interest into it. So yeah.
And Monty, how conscious were you?
I've always been
pretty
conscious of. I've been pretty conscious about it because I just hate the thought of people digging holes purely to get energy and resources all the time and just trying to find a way to keep the planet in a better state than it currently is. Back in the 70s, I was on a composting drive back then, and now, some 40 years later, we still really haven't advanced. So when it comes to the energy harvesting, it's just a continuation. It's just an extension of that methodology, I suppose, that principle.
The other thing is that obviously you found some of the. This is for both Sean and Monty. You found that there are certain constraints associated with using energy harvesting, but what have you been surprised by in terms of the have there been things that you thought that you've been able to do more with it than you originally planned or originally thought you would be able to do?
No, everything that it does, I expected it. It worked to spec. I realised that there's not much energy around when it's harvesting stuff, but what I've been focusing on is finding places where you least expect to find energy to harvest.
Sean, does that apply to you as well?
Yeah, well, I got surprised by one little thing was the LE Sense interrupt system that they had, so you could actually do a huge count up and actually not turn the main power of the microcontroller on until a set number's hit, and that way you can keep a much lower power profile until you've actually hit not just like a single rising edge, but multiple ones have happened, and then you actually turn the system on, so it's an excellent little extra counter to help save power. And that was something that I wasn't expecting. I hadn't really noticed much in other systems before, and quite like the idea because it's saving even more power in the system before it has to turn on and broadcast again.
Yeah, absolutely. This is one of the things that we are proud of, and I don't think any other microcontrollers have the LeSense system. But it can really save you if you utilize this correctly. It can really save a lot of power because really starting up the CPU draws a lot more power than doing this in hardware in deep sleep with the LeSense. So that's cool.
Fantastic, guys. Well, thanks very much for everybody's participation. If there's no other questions, then I'll close the Hangout, but I'm sure we'll meet again on this platform because I think it's quite a useful platform for these kinds of discussions.
Well, thank you to everybody, particularly those who are contending with very late hours.
Yeah, thanks very much, guys. Speak to you later. Thank you. Bye.
All right.
Thank you.
Bye. Bye.